Solar cells are an increasingly common method of generating electricity and are typically found grouped together on solar panels. Two different types of the semiconductor silicon, called N-type and P-type silicon, are used in the construction of solar cells. These are not actually pure silicon, but a mix of silicon and another element, boron for P-type and phosphorus for N-type. Because of the way boron bonds with silicon, electron holes occur in P-type silicon, whereas in N-type silicon, the bonds result in extra electrons that are free to move throughout the material. When these two types of silicon are layered next to each other, the border between them becomes what is called a depletion zone, where the electrons from the N-type silicon fill the holes in the P-type silicon, causing negatively charged ions to form on the P-type side and positive ones on the N-type side. When the silicon in the cell is hit by sunlight, electrons are ejected from the metal and move across the depletion zone, resulting in an electric potential. If you connect the two layers of silicon with a wire, the electrons will travel from the N to P layer through the silicon, then back to the N layer through the wire, generating an electric current that can be harnessed.
The first time a photovoltaic effect was demonstrated was by Alexander Bequerel in 1839. It wasn't until 1883, however, that Charles Fritts built the first solar array in New York. In 1905, Einstein published a paper explaining how the photovoltaic effect actually worked, which earned him a Nobel Prize in physics and allowed Bell Labs to develop the first instance of the modern photovoltaic cell in 1954. The United States government then funded research into using solar panels on spacecraft, and the first solar-powered satellite, Vanguard 1, was launched in 1958. Although the U.S. government's subsequent pushes for solar energy largely failed, worldwide use of solar is now on the rise as the cost of installation falls. Solar energy has experienced 54% annual growth over the last 10 years in the United States, and in 2017 the global solar market grew 29.3%.
The primary material used in solar panels is silicon, first isolated in 1824 by Berzelius. It is found in stars, meteorites, and is the second most common element in Earth's crust, next to oxygen. It occurs naturally in oxides and silicates instead of in pure form, and is in many common materials, such as sand, clay, quartz, granite, mica, and various types of gem. It is typically produced by heating silica with carbon in an electric furnace with carbon electrodes. Silicon is incredibly useful and is necessary in making concrete, brick, enamel, silicone, and glass. It is also an important component in many electronic devices as a semiconductor. Everyday objects that may include silicon are windows, bricks, computers, and cell phones, dishware, and even steel. Silicon and its products are ubiquitous and are important commercially. Take, for example, the well-known economic region called Silicon Valley. Silicon is one of the most common elements on Earth, as well as one of the most useful.